Hello, dear students. I'm glad to meet you at our course. Today we are going to start the new module, which is called Unique Buildings and Structures. And today we are going to discuss such topics as long-span buildings and structures. Let's start. Long-span buildings and structures are buildings and structures covered with long-span structures over 36 meters in size. High-rise buildings and structures are buildings and structures with a height of more than 75 meters. Unique buildings and structures are constructions and structural schemes requiring non-standard or specially developed calculation methods or verification on physical models. Buildings and structures being erected in territories with seismicity exceeding 9 points. Buildings and structures with a height exceeding 100 meters, a span of more than 100 meters, console outreach of more than 20 meters, if the deepening of the underground part relative to the plant level of the earth is more than 15 meters, are unique. The start date of using long-span structures is the 19th century. This generated the need for long-span enclosures at a time when the technology of cast iron structures was sufficiently advanced to be able to provide them. Progress from cast iron to wrought iron, then steel in quick succession provided the means to build longer and larger structures. Long-span buildings create unobstructed, column-free spaces greater than 30 meters for a variety of functions. These include activities where visibility is important for large audiences, auditoriums and covered stadiums, where flexibility is important, exhibition halls and certain types of manufacturing facilities, and where large movable objects are housed, aircraft hangars. Long-span structures are today widely applied mainly for sports buildings such as stadia, sports halls, swimming pools, ice tracks and skating rinks, and indoor athletics. There is a wide range of different structural systems for long-span sheds. Steel is by far the most common structural material used in their construction. There has been an increasing demand for longer column-free spaces to provide maximum flexibility to the interior space. The structure can be clad in a variety of ways, with profiled steel sheeting a common choice. The design of large sheds provides a wealth of opportunities for the designer to explore technology. Large flexible spaces can be provided to suit a wide range of uses. Long-span one-way structural systems spans exceeding 60 feet. A one-way structural system is characterized by relatively large linear spanning elements in one direction. Smaller spanning members are used to carry loads to the primary members used in rectangular framing bays. The main features of the one-way systems are lack of redundancy, stability during construction, stability after construction, connections, bonding, temperature movement, tolerances, shipping. Long-span two-way structural systems. As its name implies, a two-way system distributes the load across two or more members. All members in a two-way system are considered to be primary members. A two-way system is most efficient when the shape is square so that there is equal distribution along the supporting members. Types of two-way structural systems are space frame. Basically, it is a three-dimensional truss. Lots of redundancy is built into this type of a truss system. Dome. Probably the most efficient structural system. A circular dome has vertical meridian lines that act like vertical arches in compression and horizontal hoops that act in tension. Thin shell structures carries shear, compression, and tension in the plane of the shell. These structures are deformation resistant based on their shape. Membrane structures. Similar to thin shell structures, membrane structures are also considered to form resistance. However, these fabric-like membranes can carry tension only. They are extremely lightweight. Structural systems for long-span buildings can be classified into two groups: those subject to bending, which has both tensile and compressive forces; funicular structures, which experience either pure tension or pure compression. Since bridges are a common type of a long-span structure, there has been an interplay of development between bridges and long-span buildings. Bending structures include the girder, the two-way grid, the truss, the two-way truss, and the space truss. They have varying optimum depth-to-span ratios ranging from 1:5 to 1:15 for the one-way truss and from 1:35 to 1:40 for the space truss. The funicular structures include the parabolic arch, tunnel vault, and a dome, which act in pure compression and which have a rise-to-span ratio of from 1:10 to 1:2, and the cable-stayed roof, the bicycle wheel, and warped tension surfaces, which act in pure tension. Within these general forms of a long-span structure, the materials used and labor required for assembly are important constraints along with other economic factors. Materials suitable for various forms of long-span and complex structures are all reinforced concrete, including precast; all metal, for example mild steel, structural steel, stainless steel, or alloyed aluminum; all timber, laminated timber; metal reinforced concrete (RC) combined; plastic-coated textile material; fiber reinforced plastic. Common structural forms for long-span building structures are in situ RC tensioned, precast concrete tensioned, structural steel erected on the spot, structural steel prefabricated and installed on the spot, portal frame in situ RC, portal frame precast, portal frame prefabricated steel. Thank you for your attention, dear students. Next time we are going to study factors to consider before building a long-span structure. See you next time. Goodbye.